Good morning students. In last video we have already completed exercise 13.2. Today we will solve some other questions of topic conversion of a solid from one shape to another. Means there is a solid is in one shape, then you convert it in another shape. From this topic we solve some examples. So example 8, a cone of height 24 cm and radius of a base 6 cm is made up of a modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. That means here according to our question there is a cone shaped solid, then it is converted in the shape of a sphere. That means the volume of the first solid, that is the cone, is also equal to the volume of the sphere. Okay. So see here example 8. What? Now a cone of height 24 cm. Here this is a cone of height 24 cm and the radius is a 6 cm. Base radius of the base is a 6 cm, and it is made by a clay, made up of a modeling clay. A child reshapes it in the form of a sphere. Again, this is in the reshape in a sphere of sphere. Then here question said find the radius of this sphere. So according to our question, the volume of this solid cone shape is also equal to the volume of this second solid, that is the sphere. Okay. So first you find the volume of this first solid, that is cone. So here what? Now the height of conical shape, that is 24 cm, and radius of this, that is 6 cm. So what is the volume of this shape? Now the volume of a cone, that is equal to what? Now 1 upon 3 pi r square h. This is the formula to find the volume of the cone, that is 1 upon 3 pi r square h. So that is equal to 1 upon 3 into pi into r square, that is 6 into 6 into 24 centimeter. This is the volume of the first solid, that is the cone. Then again said what? Now this conical volume, a conical solid reshape in the shape of a sphere. So according to our question, volume of a cone is equal to volume of a sphere. So here we also write cone reshape in a sphere. So the volume of a cone is equal to the volume of a sphere. So let the volume of a sphere, the radius of the sphere is in r. So let the radius of a sphere be r. Okay. So now according to our this volume of a cone is equal to volume of a sphere. So volume of a cone is equal to what? 1 upon 3 into pi into 6 into 6 into 24 is equal to volume of a sphere, that is equal to 4 upon 3 pi r cube. Okay. So now both side pi cancel. So this implies 1 upon 3. 3 here it is cancelled 2. Then 6 into 2 into 24 is equal to here 4 upon 3 Okay, so this implies R cube is equal to 6 into 2 into 24 into this 4 upon 3 come to here divide, so then it will be reciprocal. So that is 3 upon 4. So 4, 6. Okay, so that is equal to how much? 6 into 2 into 6 into 3. So this implies R cube is equal to 6 into 6 into 3 into 2. That is also 6. So then this implies R is equal to cube root of 6 into 6 into 6. So that is 6 centimeters. Sorry, R is here a capital R because we will take R, the radius of the sphere is capital R. So here also we can write capital R. So R is equal to what? Another 6 centimeter. So the radius of the sphere is equal to 6 centimeter. Okay. So here only one thing is here, when we convert one solid or when we reshape one solid in the another, so then both the solid having equal volume. Okay. So I think all of you understood. Then come to next question. Question number 9. Selby's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump, an underground tank. That sump means an underground tank, which is in the shape of a cuboid. The sump has dimensions 1.57 meter into 1.44 meter into 95 centimeter. The overhead tank has its radius 60 centimeter and height 95 centimeter. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. Compare the capacity of the tank with that of the sump. Okay, so that means here two shapes. That means here a cylindrical tank is there. This is a cylindrical tank. Okay. But now here this is cylindrical tank of radius 60 centimeter. Radius is 60 centimeter and the height of this tank is equal to how much? 95 centimeter. Okay, this is the water tank and it is filled. This is filled by pumping water from a sump. There is another underground tank which is in the shape of what? Cuboidal shape. Okay, here another tank that is in the shape of a cuboid. Here it is in the shape of a cuboid. Okay, and the dimensions of this sump, that is length is 1.57 meter, breadth is 1.44 meter and height is 95 centimeter. That means 0.95 meter. Okay, so now this is the dimensions of the underground tank, that is the sump. From this sump, water filled to this cylindrical tank. Okay, that means what? The first you find, and then here question said what? Now the sump has dimension this. Find the height of the water left in the sump. After filled this cylindrical tank, here question said how much water left in this sump. So first you find the volume of this cylindrical tank that is also equal to the water of the volume of the water in this tank. Okay, so first here another thing is also given, that is pi is here 3.14. So first here you write what? Now the height of the cylindrical tank, height of cylindrical tank, that is equal to 95 centimeter, and the radius of this cylindrical tank, that is 60 centimeter. Okay, so the volume of water in the cylindrical tank after filled, when water filled, so the volume of water in this cylindrical tank, that is equal to the volume of the tank, volume of tank. So that is equal to what? Now here it is in the shape of a cylinder, so that is volume of the cylinder. Formula is what? Pi r square h. So that is equal to pi r square h, that is pi into r is equal to how much? 60 centimeter into h is 95 centimeter. So here 95 centimeter. Okay, so then, so that means here it is pi into 60 centimeter into, so that means you now here we convert it, that is 0.95 meter, here it is 0.6 meter also. Okay, so then here we write pi value is equal to 3.14 into 0.6 into, here also 60 r square, that is 60 into 60, so 0.6 into 0.95 meter cube. Okay, so this is the volume of the water inside the cylindrical tank. Then come to water. Now the volume of water inside the sump. So now the volume of water in the sump. So first here also we can write water. Now the dimensions of the sump. So here we write the dimensions of sump is 1.57 meter into 1.44 meter into 0.95 meter. So the volume of water in the sump, that is equal to volume of sump. So that is equal to length into breadth into height. This is the volume of cuboidal. So centimeter cube. So that is equal to what? Now 1.57 into 1.44 into 0.95 meter. Okay, so this is the water, volume of water inside the sump, and this is the volume of water in the cylindrical tank after filling. Then question said water. Now after filling this cylindrical tank, how much water left in this sump? So that means this is the total water minus this is the water in cylindrical tank. So how much water left in the sump? Now the volume of water left in sump after filling the tank. So volume of water left in the sump after filling the tank, that is equal to what? Now 1 point or here you write volume of water in the sump minus volume of water in tank. Tank means that is the cylindrical tank. So then here we write so that is equal to how much? Now 1.57 into 1.44 into 0.95 meter cube minus 3.14 into 0.6 into 0.6 into 0.95 meter cube. This is the water left inside the sump. So here you write what? That is equal to how much? Now 1.57 into 0.6 into 0.6 into 0.95 into 2. So here we write, when we multiply or subtract, so 1.57 into 0.6 into 0.6 into 0.95 into 2 meter. Okay, because here you see 1.57, here it is 3.14, here 1.44 into 0.95. So this is it. When we subtract, then we get this one. So this is the volume of water left in the sump. Then again question said you find, let this level of water is left inside the sump. So here question said water. Now what is the height of the water left inside the sump? Okay, what is the height of the water level left in the sump? So that means the volume of water inside the sump, that is equal to water. Now this one, so then height of the water level inside the sump, that is equal to total volume of the water divided by what? Now the length into breadth, because this much water, this is also in the shape of a cuboid. So the volume is equal to what? Length into breadth into height. So here it is length and breadth. This is same and only height is different. So then the height of the water level inside the sump, that is equal to the volume of water divided by length into breadth. So here you write the height of water left in the sump, that is equal to what? And the volume of water left in sump divided by length into breadth. Why? Now the volume of the water is what? Now length into breadth into height. So in this, okay. So then here you will write what? Now 1.57 into 0.6 into 0.6 into 0.95 into 2 divided by length into breadth, that is 1.57 into 1.44. Okay, so that means here 1.57, 1.57 cancel. So that is equal to how much? Now 0.475 meters. So here 0.6, 0.6. So that is equal to 0.36. Here, so then when we multiply this and we divide 1.44, so then here it is equal to 0.475 meter. Okay, so that is equal to how much? Now 47.5 centimeter. So the water left in the sump, the height is equal to how much? 47.5 centimeter water. Okay, then again here also question said what? Now you find the capacity of a tank. Also here we find what? Now compare the capacity of the tank with that of the sump. Means both solid, you find here the ratio between this capacity of both the tank. This is cylindrical tank and this is the cuboidal tank. So now we find what the ratio between this. So the capacity of a tank also, capacity of a tank divided by capacity of a sump. So what is the capacity of a tank? And that is 3.14 into 0.6 into 0.6 into 0.95 divided by the capacity of the sump, that is 1.57 into 1.44 into 0.95. So that is equal to how much? 0, that is 1 upon 0.95, 0.95 cancel. So then it is what? When we divide this, so that is equal to 1 upon 2. So that means the capacity of a tank is half of the capacity of a sump. So the capacity of a tank is half the capacity of a sump. Okay, so I think all of you understood to remember what, and this is the, again here we explain both tank. This is one is the cuboidal tank and one is cylindrical tank. Both dimensions are already given. Then you find both the volume of both the tank or volume of the water in the both solid, that means the cylindrical tank and this. Then again said after filling this, so then how much water is left inside this, so then we subtract them. Then the height of the water level left in the tank, so that is equal to what? And this is the water, this is also in the shape of a cuboid. So volume of water, that means length into breadth into height. So length and breadth already given, so then you can find height. So that means the volume of water divided the length into breadth, then you can get the height. Then last question is here water. Again here you will find the capacity of both the tank, the ratio between this. So that is equal to 1/2. That means the tank of the capacity of a tank is half of the capacity of a sump. Otherwise, the sum of the capacity of the sump is double of the capacity of the cylindrical tank. Okay, so I think all of you understood. In next video, we also solve some other examples of this type. Okay, thank you.